All right, hello and welcome to GLOBEBUSTERS, Season 15, Episode 3. I'm joined today by Stone G and Shane G. Welcome, gentlemen.
What's up, everyone?
Stone G is going to be doing a presentation. Oh, there he is. Stone's going to be doing a prezi tonight for us on his summation of his work on relativity theory. Kind of go over some of the stuff that he's put together over the years. Stone, whenever you're ready, good sir, take it away.
Nice.
All right, gang, how we doing there? Let me bring a few windows up so I could share them with y'all, starting with a cute little set of picture there. Cha-cha-cha.
I like to start every prezi with a cute picture of a kitten or a puppy.
Well, that's a good thing to do. Okay, yeah, so you should be able to see that window now, nice and big. Cool. Alrighty, gang. Well, hey, today we're going to be talking about Einstein's Relativity, and that entire quote theory. And I personally wouldn't use that word. It encompasses a wide spread of physical phenomena, but I would like to highlight 4 things in this presentation. So let's just bang right on into it. So since current academia are still the ones responsible for perpetrating this fantasy, I would like to start with an element which is taught at the post-sec level, and that is the speed of light and how it is treated as a, quote, invariant, regardless of reference frame. All right, let's get back over there.
There's got to be a way for you to zoom in so that we can not have letterbox or something.
Well, right. It's just a little pic. You're good on that, but you're going to see the vid nice and big that I'm about to play. This first video is from MIT and their online teaching series. This one's a 3-parter, hours long each kind of thing, and eventually they start to focus on tensors as an overall subject. But long before he gets to any of that, early in the introduction, he interrupts his lecture with a reminder about what they were taught in a previous class on special relativity. And it's only 2 minutes long. So the question is, let's see if you guys can spot the fallacy. And let's bring that up too. I'm going to stop sharing that and start sharing this other thing. My audio will be off while we're watching this. So by all means, enjoy. There we go.
So this Einstein synchronization procedure, this takes advantage of the fact, and by the way, we are not going to teach special relativity in this course. 8962, I assume you have already studied special relativity and you're all experts in this, and so I can freely borrow from its important results. This procedure takes advantage of the fact that the speed of light is the same to all observers, no matter what inertial reference frame they might be in. Okay, so the speed of light is a key invariant. Okay, it connects, because it's a speed, it connects space and time. And because it is the same to all observers, it defines a particular standard for relating space and time that is going to have important invariant meaning associated with it. Okay, so just to remind you what this means, let's see, do I have a laser pointer with me? Yeah, I might, but don't worry about it. Let's say I have a pretend laser pointer. My chalk's a laser pointer. So, I point my laser pointer at the wall, and you all see it dashing across the room at 300,000 kilometers per second. I then start jogging at half the speed of light, as is my wont, and continue to point that. You guys measure the light going across the room. You still measure 300,000 kilometers per second. I, on the other hand, measure the light coming out of my laser pointer, and I get 300,000 kilometers per second. Okay, so just because my laser pointer is moving at half the speed of light, according to you, doesn't mean the light that's coming out of it is boosted to a higher speed. If you study special relativity, you'll know that its energy is boosted to a higher energy level, but the speed of light is always just c.
Okay, did you guys spot it? Let's kill that. I can't hear you guys.
The
Oh, now I
speed
can
of
hear you.
the assumed speed of light being invariant.
Yeah, that little thing.
They
He
just
says,
shoehorn that in there.
so let's go back to sharing my cool little picture. There it is right there. And I'll even enlarge that window just a bit. How's that? Is that a little bigger?
Nice.
It's a little bit better. It's a little bit better.
Nice and pretty. Okay. Well, he says that because c is a speed, it, quote, connects space and time. And I would assert quite the contrary. Speed is entirely dependent on those two variables, distance and time. It does not connect them. It is a result of their measurement. So he asserts that the speed of light is the same to all observers. And then he lets the cat right out of the bag. And he states that because the speed of light is the same to all observers, it, quote, defines a particular standard for relating space and time that is going to have important invariant meaning associated with it. So, of course, then he whips out his little fake laser pointer, aims it at the wall, and says that we in the room would measure its speed at 300,000 kilometers per second, begins to move at 1/2 of c, and claims that he would also measure the speed shining ahead of him at 300,000 kilometers per second. Okay, even a 10-year-old can work out that he would measure the speed of his laser light to be 1/2 c. Yet they expect the entire post-secondary crowd to just roll over and accept this nonsense as a basis upon which to perpetrate the rest of the fantasy. The truth is that with simple Galilean analysis, one can mathematically prove that the speed of light is always c plus or minus v. And that v is calculated using the coordinates of the lab frame, also known as the absolute frame. Kudos to Dr. Bennett right at that particular moment. So we're going to be returning to this scenario in a couple of minutes once we've had a chance to take a cursory look at a related topic. Okay, so the second point that I'd like to highlight is the way in which units of measurement are treated in the formulae. In illustration of this point, I'd like to show you a few seconds from a lecture by the great Stephen Crothers titled The Logical Inconsistency of Special Relativity. So again, this is a three-parter, so it's going to be a little bit of back and forth here. I'm going to mix it up and share it with you bit by bit here, just with a bit of narrative. So that's with audio on. There's Mr. Crothers right there.
Shout out to Dr. Crothers.
Yeah, man, he's been through a lot. I read some of his other biological background on a website. He put some information up about how his PhD pursuit went. It's a really sad story. So anyway, so this first few seconds is something I put first in the video, but it comes much later. But I did in order to set the tone for the rest of his content. And his following comments come from the same subject about which our MIT professor was lecturing, which is Einstein's method of clock synchronization. So let's bug into that just for a second here.
And in his famous 1905 paper, Einstein defined time by means of these fantastic clocks that he concocted. I'll read to you what comes from his 1905 paper, the so-called seminal work that turned physics into a completely new paradigm. changed our conception of space and time. Well, it ruined our conceptions of space and time by turning it from physics into a fantasy land.
Okay. At first, that just seems like substanceless, anecdote and an accusation, but that's why I'm bringing the rest of this to the table. And let's see, to preface what we are about to see there, it's about the first point he's making, that he's shedding light on Einstein's mistreatment of units of measurement in his formulae, which I think he's quite correct in doing. The fact is, you simply cannot create a new dimension from existing dimensions by lumping them together. And we'll put it at that for a sec. Let's get back to.
The first thing is that if we consider now units, we might measure length in meters and time in seconds. Can you add meters to seconds? Obviously, you cannot.
Again, seems like a really simplistic thing to say, but it's actually got some very deep meaning with regard to everything I'm about to present here. There is no such unit of measurement as a meter second, is really what I'm trying to point out here. And you'll see how some of that comes into play as we progress here. So for Stephen's final point, let's first check out a diagram. So I'll stop sharing that one just for a sec. And yeah, it's a diagram that he's talking about. We need to familiarize ourselves with the broader points. So that's going to be back at the pics. Sorry, guys, this takes a while, but this is what it is to present something worth watching. Okay, so we're back to here, and we're going to this diagram right there. You can see the 4D continuum now, I hope.
Yes, sir.
Good stuff. Okay. Well, at this point in his lecture, he's speaking about the fundamentals of four-dimensional reality and the language of the geometry that he's using to represent it. Naturally, it's about three orthogonal physical dimensions and the addition of time so that we can compute C, and that's coming out from the center here, point A, out to the surface of the sphere, because this is in 3D, on point D, right about here. He spends time covering the algebra behind the three axes in getting to the point D, the length to which he uses Pythagoras in squaring them, which you can see in this base formula here. Everybody's familiar with. This is where he cites Einstein's suggestion that C times T is an equivalent value in that subtraction of one from the other must equal 0. But the point is that it isn't geometrically significant, because time is not an additional physical axis orthogonal to any of these other three. And he finishes the point by citing Einstein's use of the distance variable s as this, and he cites it as the same class of error in his mathematics. So let's just bug over to that for a second here.
Want to have a four.
Did I just stop sharing by mistake? I clicked that
Yes.
rather quick. Sorry,
Yeah.
guys. Let's do that again. Let's get it just right.
But if you want to have a four-dimensional space in pure mathematics, you have to have four independent quantities. Well, X, Y, and Z, as we see by looking up at, say, the corner of one of these corners in this room, you have X, Y, and Z. They're independent of one another. But we see that the speed between any points in that space is not independent, because you need the x, y's, and z's and the time to be able to calculate the speed. So it's not independent. The speed is not independent. If I multiply speed by time, the very same time I use to calculate the speed, that's not independent either, because it's the length of the hypotenuse of a right triangle. So to do four-dimensional mathematics, you need four independent quantities. Well, c times t is not an independent quantity. Treating it as an independent quantity by saying, well, we'll make it equal to s squared, not equal to naught, doesn't make it true. It means you made a mistake.
Isn't he great?
It's a feature, not a bug. Dude, Crothers is
That's
awesome.
right. It's a feature. So, as a postscript to this point that he just made, in full extension of it, I would cite the concept of space-time as a member of this error class. It does not logically follow that one can correctly presume to assign physical properties to empty physical space simply by representing it as an additional mathematical dimension. Okay, so that marks the end of my theme on relevancy being logically inconsistent. Get you back to the pretty pics here. There they are. There we go. Now you can see those. So let's shift the focus a little bit here from logical inconsistency to falsifiability, or lack thereof. I'm sure you guys can hear it coming, because I've done work on this in the past. Everybody has seen. It's on time dilation, and you guessed it, length contraction. So let's deal with them in order, I suppose. For time dilation, I would cite the movie industry, who have produced a plethora of science fiction plots where humans have the ability to travel nearly as fast as the speed of light. And the plot always involves how time passes at a much slower rate for those traveling in the ship. So the ship trip, in total might be, 400 light years from A to B. And let's say that the travelers were going so close to the speed of light that they only experienced a month of time while they were in transit. But the outcome is always the same on all levels. It still took 400 years to get there. And it still takes another 400 years to get back, regardless of how long, time goes in the ship while you're going. And then there's the issue of just how far humans will have technologically advanced in that same amount of time. This is when we loosely calculate the odds that humans will have developed a far faster method of travel within the first century or two after their initial departure. Kind of rendering the whole thing absolutely pointless, because by the time they get there in 400 years, they'll find out people left after them and got there before them. And paradoxical. We're slowly getting into that theme here too. But all of this, of course, assuming that space is the limitless expanse of vacuum described by the globies. But I digress. The bigger point here is that until we do have that kind of ability, time dilation theory is not even science. It can't be confirmed nor falsified. And here, this is where I jump in with the interjection, or can it? I would assert that Einstein's formulae serve to create a far deeper problem when looking at that simple MIT laser scenario. So that's going to be taking us over here to page 4, which is this little guy here that some of you may recognize this diagram here. This graph, rather. I've got to come out just a bit to see it all. There you go. How's that? Pretty. All right. This is a graph which shows the duration of 1 second and how that time of 1 second dilates with speed relative to the stationary observer. Isn't that always the key factor? The reference frame, where Einstein used to insist that a lab frame isn't necessary for proper analysis. You know what I mean? That when we look at this graph, here's E sub r, And this particular velocity right here is about 430 meters per second, which is what the globies assert the Earth is doing, spinning around and around at the equator. Okay, now S sub r here, that's the 30 kilometers per second, 30,000 meters per second that the Earth is allegedly orbiting the sun at. Okay, great, 30, right? Well, currently humans have no craft capable of traveling even at that speed. So check this pink line down here for those of you who are not familiar with it. It doesn't appear to do anything other than flatline until around 30 to 40,000 kilometers per second. It shows us how time, relative time, isn't changing in any significant way for anyone traveling less than a full 10% of the velocity of c. So in a video that I've produced on this topic about 1.5 years ago, I calculated that if we jettisoned one of a pair of atomic clocks off of Earth behind us as we're allegedly orbiting the sun, and we buzz around and whiz around here for a year, and then we pick that clock up, we recover it 1 year later, that its time would differ from its pair, which stayed on Earth, by all of 158 thousandths of a single second out of the entire year. That's how much dilation is going on at 30 kilometers per second. So when it comes back to the issue of falsifiability, we turn, of course, to NASA. What are the chances that anyone in their entire organization will show this level of coherence in their, quote, pursuit of science and arrange this kind of experiment? No takers on that estimation. Hey, are you kidding? I would also point out that NASA hasn't even got the wherewithal to launch one of a pair of atomic clocks, and send it up to the old ISS. They could have had one of these on the wall for the past 25 years, and they could constantly point at it and say, look, see, Einstein was correct. And I think we all know why they don't and won't. It's that they are too busy in the pool with their guitars, flutes, and Christmas party hats playing Feliz Navidad.
Oh man, they're doing hardcore science, bro.
For sure, that just can't stop them. That's what 70 million a day buys.
Did you see that new research paper published by the astronauts on the ISS?
I heard of one. I didn't catch it though. What was it on?
I have no idea. I've never seen one.
Oh, well, okay. Good one. Good. You got me there. Good one.
I'm not saying they don't exist. I'm saying I've never seen one.
I saw one on them 3D printing a wrench this big, a little box end wrench.
No way.
Which they could fix something on the ISS with it, I'm sure, like, oh my God. Okay, let's go back to the graph here for a second and take a nice close look at what's happening in the lower right over here, where the curve becomes significant in terms of how long 1 second lasts for someone with a speed approaching c. Now that takes us to this pretty little thing right here. I could almost get it all in there in one shot. Let's zoom out just a hair. How's that right there? You can kind of see all that. Yeah. Okay, good. So what we see is that there isn't even this is how many seconds it lasts for the stationary observer, the 1 second itself, and that it really doesn't even come to a 10th until you hit up over 100,000 kilometers per second. Okay, so I'm also showing here where 0.5 c, right about actually, wait a minute. Here, 0.5 c is right about here on the vertical at 150,000 kilometers per second. And that meets up with roughly 1.2 seconds for the stationary observer. So you're going to see on an upcoming spreadsheet that the value here is actually 1.155. But let's keep the simpler figure of 1.2 in mind for the rest of what's going on here. So I also labeled 1.5 seconds at around 210,000 kilometers per second, as well as where 1 second lasts for 2 seconds up here at 260,000 kilometers per second. So when you're right about there, you're at about 87% of C. And even then, at 80% of the speed of light, 1 second of somebody moving at that speed only lasts for 2 seconds for the stationary observer. Okay, so you can sense the non-linear relationship that's going on here. Okay, but let's take one step back and come back down to the 150,000 kilometer per second mark at 0.5 C, just like our first scenario over at MIT. And there it is again to remind you. So in this scenario, two lasers, these two here, are actually identical when they're both stationary, emitting the same frequency of light. The contrast I'm showing with the two lasers is how the frequency of light as it travels towards the wall is purely based on the speed of the laser emitting the light relative to the speed of the wall, which is presumed to be 0. So I'm not talking about how fast the light is traveling. I'm talking about how fast the laser is traveling that's emitting the light. So we, as stationary observers in the room, along with the little stick man sticking on top of the stationary laser, we all measure the frequency coming out of the bottom one here as the red frequency. And when we look at the other one, we see more of a blue frequency because it's literally twice the frequency of the first one because it's moving at 1/2 C. So our MIT professor here, he's of the opinion that the stick man standing on top of this laser up top here sees light coming out of this laser moving at 300,000 kilometers per second because, time dilation. But in my succinct and cryptic response, I would say that the proportionalities just are not the same. So let me explain all that and what's coming up here. So here, the light above is propagating at twice the frequency of below. And that's due to the fact that the laser is moving half the speed of light. But at a speed of 1/2 C, time is not passing at 1/2 of the rate of the stationary observer. As we saw, at 150,000 kilometers per second, 1 second for the traveler is only 1.2 seconds for the stationary observer. Not 2. So when we apply real world figure to Einstein's time dilation formula, we see how quickly the formula falls apart. There is the matter of how those on board here, on with the moving laser, doing this at this velocity, it's a matter of how they even manage to get to a speed of precisely 150,000 kilometers per second. We're talking about a distance over time measurement when time is changing with distance over time. So I'm going to say that again, just to make sure you understand the relationship and how this is in a very calculus sort of way. Okay, that distance over time is changing with distance over time. Okay, the traveling stick man here, let's say he's on a train instead of standing on top of this laser. Okay, so if he was in a train, he on the wall would have his own little clock in the control room, and it's ticking the seconds away, which he can use with his odometer or whatever other distance measurement gear he's got there, taking a ruler or whatever it's going to be, also on board. Let's say they're hooked up to the wheels on his train or something like that. Okay, but the raw computation, when taking the lab frame into account, is not what they would have you assume. At 150,000 kilometers per second, one of the traveler's seconds lasts for 1.2 seconds in the lab frame. So when this guy on his train makes a first order calculation of 150,000 over 1 second, he's actually only going that 150,000 kilometers over 1.2 seconds in the lab frame, which converts to the speed of only 125,000 kilometers per second. He actually has to be going just over 210,000 kilometers per second, according to his own frame of reference, in order to actually be going 150,000 in the lab frame. You guys see that proportionality?
Yeah, that's crazy.
Isn't it?
Dude, that's insane.
That's what the math says. This is what Einstein's formulae dictate. But they don't point it out in class.
How'd
And
they
everybody
get away
who's
with
there,
that part of
what's
it? How'd they get away with that part of it? That's insane.
How did they get away with it?
They should be equal. They can't have a third. Oh, I've never heard that one before. That's insane.
Isn't it? But that's the math, and I'm about to prove this to you numerically using their formula in a cool little spreadsheet. And like you know, I always do when I prove a point is I like to make it irrefutable and mathematically, arithmetically in this case, obvious what's going on. So for those who didn't catch it the first time, I'm going to reiterate that because this is one of the bigger points of what's going on here and how none of this is valid. And you're going to see it that it just gets worse from here. Okay, so we're talking about this dude up here, and he's on his train, and he's going half C. Okay, but he's trying to go 150,000 kilometers in a second. Well, let's say he's got milestones on the ground, so he knows how far 150,000 is. Say, all right, and he knows that he went from there to there, whatever that distance actually is in the lab frame. He knows he went those 150,000 kilometers in one of his own seconds. But because he's going 0.5 C, time dilation kicks in, where he only experienced a second in measuring that 150,000 kilometers. We in the lab frame measured 1.2 seconds. So when you take it, it's actually in the lab frame that he only went 125,000 kilometers in his dilated second. That in order for him to do 150K in the lab frame, he actually has to do, according to his own gear, 210,000 kilometers per second. I hope people are keeping up with that because it reaches nonsensical proportion a few more ticks up on the scale. This is also what I want to show you. So when we look at the effect of time dilation on any speed measurement that this traveler could take using the lab frame stationary objects, milestones, or physical reference points seen as stationary relative to the lab frame, he will never reach the speed of light according to the clock he's using on board. Oh, wow. So as he moves at 0.5, he'll be seeing the stationary world whizzing towards his aft. He'll be passing stationary objects and use their distance in between to calculate his speed. And he's got the clock on the wall. And in his scenario, he approaches at 150. But time dilation, as he attempts to exceed 150,000, actually overtakes his measurement. So I'm bringing you down to what's going on with the spreadsheet. And let's just tighten that right up there. Oh, it's got to be zoomed out a little bit more, I guess, because there's a lot of numbers. Right about there should do it for everybody. Okay. The fact is, using his clock on board, he actually has no way of knowing his actual speed as he approaches C. Even as he accelerates in the lab frame. In using the clock on his wall, his distance over time calculation will be telling him that he's decelerating. In fact, it'll tell him that he's coming to a complete stop as he hits light speed. You ready for this? Okay, the left side of this spreadsheet, the left half, cut down the middle right here. That's all about time dilation versus actual speed. And on the right side, we're going to additionally take into account length contraction for the net distance over time measurement. So constants are up here on the top left. So you can ignore the C minus V column immediately. It's merely there as a reciprocal reflection of how much less than the speed of light v is at each particular point, at each velocity. So the two simple v in meters per second columns, they're identical. One here, one here. And we are using each of them to produce a dilation and a contraction factor, which are the delta t in seconds and the L for length in meters column over here. Okay, great. Well, constants top left, that's what we're doing with those. Now, what else do I want to say about this? It's a bit hard to see, but in this column only, in the delta t, I'm showing 9 decimal points, just so that you can see, when it becomes significant, a billionth of a second in change, relativistically speaking, at 10,000 meters per second. Okay, great. And the rest of them here are 6 decimal points, all the V frame and the L. This is 1 with 6 zeros, etc., all the way down. Same with all of these. In case you can't get it, there's the decimal point there and the decimal point there at 6. Okay, so just for a second, I'd like to take your attention to where the 210,000 kilometer per second mark is here, right there. 149,870,178. That is 149,000.8 kilometers per second. And that is as fast as his instrumentation is ever going to show him that he's going as he continues to accelerate. This spreadsheet data has produced 2 pretty little curves, which I think beautifully paint the picture regarding how nonsensical this theory really is. You ready? Here's picture number 1. And here we are up top. This is the lab frame velocity across the bottom, right? 210,000 is about here. And there we are at 0.5 C. According to his instrumentation, he's doing about 150K right there. Isn't that nice? Okay, well, here's where the globies jump in to save the day. And they're going to go, well, that's just the time dilation effect. It's going to swing back the other way for sure when we apply relevancy to the length part of the distance over time calculation. Length contraction will save the day, of course, silly flirts. Well, actually, it makes things a little bit worse. When we apply it, the length contraction formula, which is this puppy here, to the onboard distance time over calculation. Let's see, where did I place that? So there's the V frame, okay, and then there's the length, where we say he went, say, 220,000 kilometers, but actually he only went about 2/3 of that because of the speed he was going there. So when we apply the distance over calculation speed over here in the resultant, you'll see that the biggest number here is about 115,000 kilometers per second when he's already traveling in the lab frame 180,000 kilometers per second. So even as he accelerates, applying both of these, his speedometer or his distance over time calculation will tell him that he is slowing down as he continues to accelerate. So, there's an argument here, and I will concede it to the globies immediately, that we could rule out length contraction altogether by using beacons, physical milestones that are stationary, already measured out in the lab frame. They're precisely 150,000 kilometers apart. And I suppose, yes, that is true, that we could take this factor out, I guess. But it's the weird thing that even at 150,000 kilometers per second, the distance that you're measuring will actually appear to be 1,155%, or I guess 115, I should say, 115.5% of that 150,000 kilometers when he's doing 180,000 per second. I hope I'm making that clear, that if he's doing 180, it appears like he's doing 115.1 thousand kilometers per second. And it's because of the length contraction at that speed. The distance that he's measuring is a fair bit shorter than what we're measuring in the lab frame. That is the nature of length contraction. So backing it up a step, if we're only taking time dilation into account, I think the point that I'm making here is still fairly coherent. Einstein's relevancy is not only logically inconsistent, but also paradoxical. What I didn't show you was the resultant curve from this second additional element here. That I showed you where we're at, peaking at 210 here, but hey, take a look when you add it in. There's the original one I showed you, and there's when you add dilation to it. That it actually makes it worse, that you're not actually going anywhere near as fast. You're only doing 115 right here at 180 in the lab frame.
Now they should be proportional, right? Like if it was mathematically like on the up and up. Those two curves should be the same, right?
Essentially, you're looking at the effects of this whole nonsense about v squared over c squared, that it's present in both. This root of 1 minus v squared over c squared is the problem, mathematically speaking. This is why these two are actually produced, is because as you go faster, what you measure is actually shorter. As you go faster, time that you measure is actually taking longer. So when you compound them, the effect is more profound. Yeah. I'm hoping that makes sense to the gang, and if it doesn't, go back and play it a few times. You know.
Yeah, it's crazy thinking about the change in relative distance for the moving observer and how that plays out relative to the lab frame in terms of the timing difference created by his dilated time versus what we would measure in the lab. And like, that's hilarious, dude.
Precisely. It's exactly what I was first stressing, that both distance and time are changing with change in distance and time, distance over time. You know what I mean? That the faster you go, the more both of them are changing.
Yeah, you did a really good job of illustrating it. This one right here really brings it home.
that is what they say though, right? That like within terms of V, if you can only change the other two to keep C constant, these are the things you have to change in the lab frame, which when you graph it out looks ridiculous,
isn't it? It's absolutely amazing. What's that?
I was gonna say, yeah, without graphing it out, you just kind of intuitively think about them as being the same. But yeah, seeing it relative to the lab frame is GG. Like, that's insane.
Takes me right back to Ernst Mach, one of our heroes. Yeah, two quotes. One that he said famously was, "I can accept the theory of relativity as little as I can accept the existence of atoms or other such dogmas." I'll say that again because I screwed it up. I can accept the theory of relativity as little as I can accept the existence of atoms and other such dogmas. And more importantly, the one that most people are a little more familiar with, and I placed at the end of my Einstein video, he said, "Where neither confirmation nor refutation is possible, science is not concerned." And
that's a banger quote.
Nice.
I couldn't agree more. Hey, gang. I mean, logically inconsistent, paradoxical, and nonsensical here are the polite adjectives that I would use in description of relevancy. And as a postscript, I would offer that in objective fairness to Einstein, later in his life, he was indeed also quoted to have mentioned that, quote, "In the narrower sense, special relativity suffers from an undeniable fundamental defect." So I'm hoping that this presentation here that I've just shown you has shed some light on that very defect. Yeah, thanks for your time and attention, everyone. I hope you enjoyed it as much as I did.
It was
banger, man.
it was great and it had great visuals. Can you go back to the first slide with the laser pointers?
Oh yeah, this guy here.
Yeah, so that was one of my favorite ones because that dude with the chalkboard at MIT or whatever is happy to run across the chalkboard and say all that, but that contradicts measurable Doppler frequency shift and interferometry. They measure not only the frequency shift but the wavelength change, which creates the overlap for there to be the perceived c plus or minus v in physical reality as a measurable difference due to velocity. And they're like, nah, but it's just the frequency though.
Well, isn't it present in
Now you're
radio
catching
waves
up.
too? I remember
What was that?
Bennett talk. Isn't it present in radio waves too? There's a C plus V effect in
Yeah.
over radio wave propagation.
Oh yes.
Yeah.
Oh,
Bennett
yeah.
talks about all the time. So it's always the same across everything. People
It's
are like,
straight
no,
up
it's not real.
Doppler.
What?
It's straight up Doppler and Galileo all the
Yeah.
way, man. They had it. They always had it, and everything else people have been trying to supersede it with is nonsense.
Yeah, and
Just
and
like
to add to the Einstein clock synchronization mythology. So what they're saying with Einstein clock sync is that if you send a signal to a clock, assuming the speed of light symmetry, when it's halfway on its signal back, they send another signal out, and that like cross references this constancy of the speed of light for them. So then like they're in sync or whatever. Now, what actually happens though in reality is they have to constantly correct the clocks for the Sagnac effect because the whatever the satellite is, it's losing time with respect to itself proportional to its own velocity. So anytime it crosses two ground stations, they send a correction signal to it. It doesn't just magically stay in sync with the Einstein stuff. Like it's not even a real thing.
yes.
Like in reality, like they can't even make it work.
Exactly. It's not even a real thing. And like you have been researching for 4 months with Shane and others. It's everybody looking at the GPS and the code and what they don't tell you. You know why they're not telling you? It's just too obvious. Is that it's not in the code. They don't need it because we're not moving.
Dude,
It's
not only do they not need it, they use Galilean absolute time and space transformations between the ECI and ECF. So like the whole mythology of like doing a Lorentz transform, it's not even in there. It's crazy.
No, they just wanted you to learn it and think it and pretend to progress scientifically based upon it when it is not a solid foundation, not logically, not physically, not mathematically, none of it. It's just utter failure as science. And I think, guys, it's been over 100 freaking years. Can we just let this go and get back to real science and get back to real scientific method, get back to empiricism, get away from dogma just for a while and see how things go?
Well, then we'd run
a
the
couple of
danger
years. That's all I'm
progressing.
asking.
So
What was that,
we
Shane?
can't, then we run the danger of progressing science and inventing things and having energy. So I'm going to say no, we can't do any of that. What we're going to have to do is focus on duality, particles, and light BBs and see how long.
Yeah, we can't have any of that. It's all QED, bro. It's all QED. Okay. Well,
That's
for
awesome,
everybody who's
Prezi.
thanks, man. For everybody who's still with us, and I'm kind of cruising the chat here to see if there were any valid questions, but it looks like just a bunch of bickering.
Yeah, well, I think somebody took care of them. I don't know if anyone asked any real questions though.
Yeah. Well, okay. So for you guys that are still there and paying attention, these are the rewards at the end. I got a video or two from the past that apply to what's going on here.
Oh yeah, we're gonna
And we'll
rock out for the end.
Thou shalt rock out for a while. So gonna go with the more general one first. Everybody knows Thomas Dolby, I'm sure. And let's just set that up.
Propagation.
Well, no, Thomas Dolby did not sing about light propagation.
Dude, I had a 50-50 shot, bro.
it was a good try. It was a good try. But I don't know. No, it's about blinding us with science. So let me mute up here. Get my little hide thing out of the way.
Oh yeah, this one was for
Enjoy.
Lily's birthday, wasn't it?
It was. There's a little bit of homage to Lily in there, just for a couple of seconds. But I think the rest of it, Shane stole a big chunk of what's around 2/3 of the way, 3/4 of the way through this video, and put it on Twitter. It's like, yeah. So enjoy, guys. Let's see what's up. Yes, but as a noted scientist, it was a bit surprising that the guy blinded us with science. I know. I know.
Gravity and motion, a space and time necessity, neutrinos in the ocean, cosmic rays in harmony. They blended you with science. Should take some trigonometry when he's writing formulae. Science. I can't see the time delay. Science. It's phony fabrication. He's pushing relativity, a clever machination. Lawrence is in harmony. He blinded us with science. He blinded us with science. I should have taken QED. Little waves of gravity. Science. I can smell the fertilizer. Science. Gigantic balls in motion. That when there is number 3. Can't measure time dilation. Turns out we don't have the speed. He blinded us with science. He blinded us with science. Shut up and astronomy. Good heavens, Mr. Lihana, you're beautiful! He just can't prove it! Just formulae again! He wrote it up and I can't test anything! Can't refute it either! It's just a farce!
And no falsification.
What? It's general and special! When he squared the phi with C, we're nowhere near the threshold. You can call it fantasy. He blinded us with science. He blinded us with science. He blinded us with.
All right. I think you guys get the point on that one.
That was awesome.
It blinded us with science.
Totally. And one more special treat just for those who are still paying attention, still with us in the live. Hey, everybody. Yeah, this one is indeed about light propagation and does rock even a little more than the last one. So let's line that up. Nope, not that one. Oh, we got to actually bring the window up. You can't have the window hidden. That's hilarious. Okay, propagation with audio. Yes. Enjoy. Particles of mass that's all round.
Talking about light propagation.
Something that just can't be found.
Talking about light propagation.
Acting just like waves too.
Talking about light propagation.
That's a lie, I thought you knew.
Talking about light propagation.
This is light propagation. How does it come from years away?
Talking about light propagation.
All that time reaching us today.
Talking about light propagation.
Gravity don't cause no deviation.
Talking about light propagation.
That's the deal with light propagation.
Talking about light propagation.
Light propagation,
Talking about
baby.
light propagation.
An isotropic plane is
Talking
day.
about light propagation.
Ether's here and it's here to stay.
Talking about light propagation.
Ain't no crazy postulation.
Talking about light propagation.
I'm just talking about light propagation.
Talking about light propagation.
There's light propagation.
Talking about light propagation.
C plus V going up and
Talking about light
down.
propagation.
Back and forth to your side of town.
Talking about light propagation.
Dang Wang had a lot of nerve.
Talking about light propagation.
Zero motion straight off.
Talking about light propagation.
There's light propagation.
Talking about light propagation.
There's light propagation,
Talking about light
baby.
propagation. Talking about light propagation.
There's light propagation.
Talking about light
There's light propagation,
Talking about light
baby.
propagation.
Light propagation.
Classic. Yo.
Absolute
Courtesy
banger.
of your friendly neighborhood ManofStone.
Well done, lad.
Many thanks. Many thanks. Did anybody check for questions?
I saw someone in the comments say that the analysis from Crothers was really awesome. How he showed that adding a unit of time to actual dimensions that in reality are orthogonal to one another. You can't just strap on an abstract concept to one of those bad boys and go, hey, we're now in a 4-dimensional continuum. Anyone want to
That's
play?
right. Yes. Yeah, nobody said that, but I appreciate it. Just
No, I definitely saw someone in there say that.
Well, we got a lot of thumbs up going on in the comments, that's for sure.
So, and someone
happy
asked what
people.
invariant means earlier.
Invariant. Well, that's the whole thing that the MIT professor was trying to bang off all quick with maybe 3 sentences to consider. It's that they're applying invariant properties to the speed of light, saying that it's the same speed to all observers regardless of reference frame. And that's just fundamental nonsense, arithmetic nonsense, Galilean analytical nonsense that you obviously a 10-year-old, like I said, can figure out that if someone's doing half of something already and the velocity coming out is the whole of something, that there's a half, you're going to subtract from the whole to produce a net figure of a half of the net velocity. I can't help people who don't understand that.
But Stone, you know what they do to pacify the young mind learning this is they say things like, well, at relativistic speeds, Galilean velocity addition breaks down. What? How does it break down? What broke it? Dude, the young inquiring mind should ask, what happened to break Galilean velocity addition? What was that pivotal moment when they realized when they add 1 + 1 together, it doesn't equal 2 anymore? What happened? It was Mickelson and Morley. It doesn't break down. That's retarded. They literally
just hand me the Coles notes and we'll work it out. Okay. I don't have time for this.
That's insane. Yeah. Awesome president.
Many thanks, man.
Good All right, lads. We will be back next week with a little something special planned. Hopefully that goes through. Won't say too much about it, but if there's not anything special, it'll just be the regular awesome episode that we get, and it just will be missing that extra special piece that would have been if what I have planned comes through. So we'll be doing that next week, and then we'll of course be back on my channel on Monday for Celestial Theodolite update number 42. We're going to be going over the concept of why the globe predicts the earlier timing specifically, because there's been a lot of talk about that, a lot of contentions. So we're going to really hone in on that on Monday. And then on Tuesday, we'll be back on Ether Roundtable, probably reading a paper or whatnot.
I hope.
And hopefully it won't be, hopefully it'll be a good one. All right. Well, we'll see you guys throughout